Graphing f of x equals a times the quantity of x minus h squared plus k. So this is known as vertex form. So this is a quadratic function because it's a degree of 2, but this is in vertex form. So you're going to learn that h and k will be your vertex. So let's look and see what we have. So we have state standards again. We're going to create, solve, use, graph, interpret, sketch, show. All of these are key terms that we're going to do, some of the same standards that we've looked at before. So be familiar with what you need to do to meet the state standards. All right, the success criteria. It takes the state standards, makes it a little bit easier to understand. So this is what you need to be successful. Identify even and odd functions. Graph quadratic functions of the form f of x equals a times x minus h quantity squared plus k. Be able to compare the graph of f of x equals a times x minus h squared to the graph of the parent quadratic function, and compare the graph of f of x equals a times x minus h quantity squared plus k to the graph of the parent quadratic function. All right, so this one does not have a vertical shift. This one does. So this one will have a horizontal movement. This one will have horizontal and vertical. And depending on what A is, it could also have a stretch or a shrink. All right, vocabulary that you need to know. Even function. A function y equals f of x is even when f of negative x equals f of x for each x in the domain. The graph of an even function is symmetric about the y-axis. All right, symmetric about the y-axis. Good to know. Odd function. A function y equals f of x is odd when f of negative x equals negative f of x. For each x in the domain, the graph of an odd function is symmetric about the origin. Vertex form of a quadratic function. The vertex form of a quadratic function is what you've been seeing up in all of these. So this is considered vertex form. F of x equals a times the quantity of x minus h squared plus k, where a is not 0. This can't be 0 or it would no longer be quadratic. You have to have that squared term in order to be quadratic. And 0 times anything is 0, so that would just be k, and that would not be a quadratic function. All right, example 1. The first thing we need to do is determine whether each function is even, odd, or neither. So let's look at a part. F of x equals 2x. All right, to review again real quick, an even function is when you have f of negative x equals f of x. An odd function is when you have f of negative x equals negative f of x. So the first thing we need to do is substitute negative x in for our function. So we're going to say f of negative x, and f of negative x means I have to substitute negative x over here as well. All right, so I'm going to have f of negative x equals 2 times negative x is negative 2x. All right, so you can see that f of negative x equals negative 2x. And what does that mean? That means if I take f of x and I times it by negative 1, that's what that is. So I'm going to have f of negative x equals negative f of x. All right, see, f of x is 2x. This is negative 2x. So if I have negative times f of x, that is this. All right, so is that even or odd? You have f of negative x equals f of x. F of negative x equals negative f of x. Since that is this one, we can determine that this first one is an odd function. That means it's going to be symmetric around the origin. All right, I'm going to swap out my stylus pen here and see if I can get one that works a little bit better. I think my stylus pen is just getting a little bit too old. All right, so I have g of x equals x squared minus 2. So let's substitute negative x in and see what happens. So I'm going to have g of negative x. All right, that's already looking better. Equals, and I'm going to do negative x squared and then minus 2. All right, and then I'm going to simplify. So I'm going to say g of negative x squared. Anything squared becomes positive, so that's going to be x squared minus 2. All right, x squared minus 2 is just g of x. You can see that is what we started with. So we can say g of negative x equals g of x. All right, if we come up here and look, f of negative x equals f of x. F of negative x equals negative f of x. This is g of negative x equals g of x, so that's going to be the first one. So we can determine that this one is even. All right, C part, h of x equals 2x squared plus x minus 2. So we're going to do the same thing. We're going to have h of negative x equals 2x. Well, hold on. I'm going to substitute negative x in here as well. All right, so negative x squared plus, and I'm going to substitute negative x in place of x there, and minus 2. So if I want to simplify, I'm going to have h of negative x equals negative, nope, anything squared is positive. That's going to be a positive. Negative x squared is positive x squared, so that's going to be 2x squared minus x in the middle minus 2. All right, now, so h of negative x equals 2x squared minus x minus 2. We know that h of x equals 2x squared plus x minus 2. So does that equal this or this? Well, what would negative h of x be? Well, negative h of x would be negative 2x squared minus x plus 2. It would be the opposite sign on all of those. So this is not that because it has a negative in the middle, and it doesn't have a negative here, so that's not that. And would it be considered even? Is it this? Did you get what you started with? No, because the middle sign is different. So because it's not negative f of x and it's not f of x, that means this one is neither even or odd. So this one is neither. And again, you're just checking to see. It would be even if it ended up to be this. It would be odd if it was the opposite of this, which would be negative 2x squared minus x plus 2. That's not what we got. So because it didn't end up being either one of those, it's neither. All right, example 2. Graph g of x equals 1/2 times x minus 4 quantity squared. Compare the graphs to f of x equals x squared. Again, this is your parent function. This function is already graphed here. The parent function, the parent quadratic function, if you don't know, is going to always have negative 1, 1, 0, 0, and 1, 1 as 3 points in your parent function. So that is your most basic quadratic function right there. All right, so to graph this one, we can see that it's in vertex form. All right, so HK is your vertex. This one doesn't have a K, it just has an H. So that means your vertex is going to be H0. So we can go ahead and graph H0 because the axis of symmetry is going to go through that point. So in this case, H is 4. So that means my vertex is going to be 4, 0. And that just comes from your equation. So if I come over 1, 2, 3, 4, 0, I can put a point there. And then I need to find other points. All right, so I could also just pick a point to the left of 4 and plug it in. So what is an easy point to plug in? Well, 0. 0 is an easy point to plug in. So if I plug in 0, 0 minus 4 is negative 4. Negative 4 squared is positive 16. 16 times 1/2. Half of 16 is 8. All right, so if I have 0, I plugged it in and I got 8. All right, I know I did that quickly, but I feel like at this point you should be able to do that. Plug in a number here. Just look at it. 0 minus 4. That's -4. -4 squared is 16. Half of 16 is 8. So I solved for y, or in this case g of x, simply by plugging in 0 into that equation. All right, so 0, 8. So I've got 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, we know this point is going to be reflected across the axis of symmetry. So I'm going to go 4 points in the other direction. And that's going to give me my third point. So you need at least 3 points to graph a quadratic function. So let's go ahead and see if we can graph this. All right, so we can see what this function looks like compared to the parent function. So you can see that there is a horizontal movement. So from the parent function to the translation, it has moved over 4 units to the right. You can see that both graphs open up. So that means they both have positive a values. And you can see that the graph of g is wider than the graph of f of x, and that's because of the 1/2 here. You can see that the axis of symmetry is going to be different. For the parent function, it's 0, and for g of x, it's x equals 4. So their vertexes are different as well. So they do have some things that are similar and a few things that are different as well. But it's that easy to graph the function, and not difficult to graph either. If you know how to find a few points on the graph, you can sketch that curve. All right, take a couple minutes, look at the self-assessment. When graphing a quadratic function, why is it helpful to identify the axis of symmetry? So go ahead and jot down your thoughts on that, and when you get ready, unpause the video and let's talk about it. All right, hopefully you pause the video, take a couple minutes to think about this and jot down your answers. All right, again, it says when graphing a quadratic function, why is it helpful to identify the axis of symmetry? Well, remember the axis of symmetry goes through the vertex. And if you find the axis of symmetry and then you identify a point on either side of the graph, you can use that axis of symmetry like I did to reflect that point over to get another point. So it kind of helps you graph points quicker if you have that axis of symmetry. Depending on how many points you want to graph, you need a minimum of 3. If you have your vertex and 1 on each side of the vertex, you can sketch a pretty good curve. But having that axis of symmetry helps you know where to reflect the point across.